So let's start off with question A, right? Or part A. Let's find the vertical asymptote first. So how do we do that? The way we find the vertical asymptote, VA, is by setting the denominator equal to 0. So denominator equals 0. Okay? Now, so let's do that in this function here, right? So x plus 2 equals 0. Remember, we're starting off with a, right? All I'm going to do is an easy isolation. I'm just going to subtract 2 to both sides, right? X equals -2. Great. So that's our vertical asymptote, right? So it's at -2. I will I will actually bring it over here, right? So VA equals -2. Cool. All right. So now we have the horizontal asymptote, right? So the horizontal asymptote is given when the degree of the numerator and the denominator are equal to each other, right? In this specific equation. So let's look. What are the leading degrees in the numerator and the denominator? Well, here we can see it's 1, and here it's also 1. Yeah? Cool. Great. So now that we know that they're both 1, that means they have the same degree. And now I have to look at their leading coefficients, right? So the leading coefficients here is just going to be 1 and a 1, right? So HA, x to the power 1, x to the power 1, right? Now, since their leading coefficient is 1 and 1, this will become 1 over 1, which means our horizontal asymptote is found at y equals 1. At y equals 1, right? Y equals 1. Okay, so I'll also write that down. Okay, so now we have our vertical and horizontal asymptote. Now let's try and find our x-intercept, right? So our x-intercept, that's when y is equal to 0, right? If we look at the graph here, any x-intercept, right, y will equal 0, right? Because we're looking at where the points cross over the x-axis, okay? And I should label this x and y, okay? So let's do that, right? We have y equals x. Let me erase this. So like I was saying, now what about our y-intercept, right? When y, so when we're looking for our y-intercept, our x will be 0, right? But look, when x is 0, we already know that y is equal to 0, right? And since we know that this is a one-to-one function, we know that our x-intercept will also be the same thing as our y-intercept, okay? So this doesn't happen very often, but it's really important to know when this happens, right? So yeah, I'll repeat that again. Since we already know what the value of x is going to be, which is 0, we already know what x equals 0 is. We know that what that value is. It happens to also be 0. We got that from our previous intercept. It means that we only have one intercept, okay? So the same thing, and that'll be at 0, 0, okay? Cool. So let's start to graph this, yeah? Now, obviously, that brings us to the question of like, well, what are these values of when we graph them, right? So let's use our table of values, right? Right. So x, y, -2, -1, oh, -1.5, -1, 0, 1, 1.5, and 2. Okay? So these are the values we're going to use to graph this whole function. Okay? So let's just start plugging in values. I'll do this quickly and then skip through this. Okay, so I finished calculating all the points. Important to note that when x is -2, that's a vertical asymptote, so our y value does not exist. Okay, now let's just get to graphing, right? So at -1.5, we'll have -3. Let's see, that's around here, and then let's see. 2, 3. Cool. So that's our first point. And now, let's see, we have -1, -1, right there. And then we have 0, 0. Cool, we have that. 1, 1/3, so right here. Just like that. You have 3/7, which is around 0.4 for 1.5. So I'll look like this. And then we have 0.5 for 2, okay? So not perfect, but this gives us the general idea of what this graph will look like. Remember to not ever touch the asymptotes. The asymptotes, just for clarity's sake, are the dotted lines. So yeah, they're the dotted lines. We don't ever want to cross over them, okay? Cool. I also need to do values over here on the left side, right? So to the left of the vertical asymptote, basically we're going to look for values that are lesser than -2 for our x values, right? So let's go do that. I won't need too many, but I will go calculate them, right? So let's do -3, -4, -5, and then let's also do -2.5. Okay, so I'm gonna go calculate these, and then I'll be back. Okay, so I just finished calculating these points. Again, super easy. Just plugged in my x values right into the A equation, because that's what we're doing right now. And yeah, and then I found my y values. Okay, cool. So let's go do this, right? So we have -3. Let's see, let's say it's around there. These values are going to get pretty high up, so I'm actually going to add a little bit more tallies here, or markers. Again, your graph doesn't have to be perfect as long as it still mostly contains like what the rough shape of it is, right? And that's because we're graphing by hand, right? 1, 2, 3. That's -3. It's gonna go up 3. So 1, 2, 3. So that's around there. Okay. You have -4, which is 2. 2. And then we have a -5, which is 1.66, right? That's around here. And then -2.5 is 5, right? So that's the halfway point between -3 and -2. That's 5. So 1, 2, 3, 4, 5 up here. Okay, cool. And now we can kind of connect these lines or these dots to make a line. Cool, great. That's how we graph this, right? So what we did, right? Let's recover the steps. So we found our vertical asymptote by setting the denominator to equal 0. We found a horizontal asymptote because we looked at the degrees of the leading polynomials, right? We noticed that they're the same degree. So then we can compare the leading coefficients, which in this case is 1/1, which means our horizontal asymptote was 1. Okay. Now we found our x. Now we found our x-intercept by setting y equal to 0 and then solving, right? And then same thing with the y-intercept, except now you're setting x to equal 0. Okay. Cool. Awesome. Let's move on to the next question. So question B is y equals 2x plus 5 divided by x minus 1. Okay. So let's, again, same steps as before. Let's just find the vertical asymptote here. Okay. So we're going to find that by setting the denominator to equal 0, right? So in this case, x minus 1 equals 0, right? So we know that our vertical asymptote here, and we just plus 1 on both sides, you have x equals 1, okay? So x equals 1, that's our vertical asymptote. Okay, now let's find the horizontal asymptote, okay? So horizontal asymptote, we compare the degrees of the polynomials, which in this case, the highest degree for each of them is x to the 1, right? Since they're the same, what we can do is compare the leading coefficients, right? So we have, let's just write this out, 2x to the 1 over x to the 1, right? And there's always a 1 hidden in front, right? These will cancel, and they're left with 2 over 1, or 2, right? So our horizontal asymptote will be at 2, right? At y equals 2. Now let's find our x-intercept, right? So we have to set y equal to 0, right? So I'll just write this out, x-intercept, and then y equals 0. So 0 equals 2x plus 5, x minus 1. Okay? Now, what we're going to do, multiply both sides by x minus 1. So you're left with 0, x minus 1 equals 2x plus 5, x minus 1 multiplied by x minus 1. These will cancel, and this becomes 0, right? So you have 0 equals 2x plus 5. And now, what we're going to do, we're going to subtract 5 by both sides to try and isolate x, right? Because we want to see what the actual x value is when y is 0. So, negative 5 equals 2x. And then we're going to divide by 2, so this becomes negative 5 over 2 equals x. In other words, x equals negative 2.5. Okay? Now let's look for our y-intercept. Our y-intercept is when x equals 0. Okay? So let's do that. We have y equals 2 multiplied by 0 plus 5, 0 minus 1. Okay? So this is gone. This is gone. We're left with y equals 5 over negative 1. Cool. So this just means y equals negative 5, right? 0, negative 5. Awesome. So now we have everything to graph our function. Yeah. Vertical asymptote. That's when x is equal to 1. All right. So let's say we have like, right? Oop, that's wrong. Oh, that's right. Oh, that's wrong. Nope. So let's start graphing. Let's do our vertical asymptote, which is when x is equal to 1, right? So just draw a dotted line. Helps us mark it. You don't have to do this, but it helps me remember what my vertical asymptote is. And our horizontal asymptote is when y is equal to 2. Okay, so let's do that. Oh, and of course, we need to include our x-intercept, so negative 5 over 2. So that's around here. Maybe a little off, but, you know, as long as it's roughly accurate. And then here, at y equals 0, 0, negative 5, that's our y-intercept. So now what we're going to do is we're going to actually do our table of values. Right? So let's just do some points here. Yeah, that'll work out. We'll do negative 2, negative 1, 0, 1, and 2. It doesn't really matter what points you pick. Just as long as you pick some points that are around your vertical asymptote, just to see how your function behaves, yeah? So, let's do. So all I'm going to do is, once again, I'm going to just use my calculator and plug in these values, right? Okay, so I was able to get some more points. And all I'm going to do is I'm just going to put them onto our graph paper here. Let's see, negative 2, that's 1/3. That's pretty low. Again, my numbers might be a little wrong, right? Or my actual graph, my scale might be a little off because I'm doing this by hand. But hey, let's, we work with what we got. So negative 1, that's negative 1.5. I'll be around here. Cool. So we can connect these bottom points together, right? Remember that your graph can never cross over your horizontal asymptotes. Okay, cool. Now I'm going to do a couple more points just so I can see what this right side looks like here, okay? So that's going to be 3, 4, right? 3, 4, and 5, let's say, okay? So I'm going to calculate these and I'll be back. Okay, so once again, all I did was plug into my x values here in the equation b, because again, we're doing b. Then I've just found out what my y values were. Okay, so when we have 3 and 3, I'll become 5.5. So let's see, 1, 2, 3, 4, 5, and a little bit above that, okay? So right around there. And now we have 4. 4. So 1, 2, 3, 4. And a little bit above that. And lastly, we have 5 here, right? So 5 is 3.75. So 1, 2, 3, and right there. Okay. Cool. So now we can see what the graph of this looks like. Awesome. Okay. So that's what this graph, that's what the graph of this function looks like. Okay. Again, not perfect. Did this by hand, but it will be good enough for when you're doing this on paper. Okay. And yeah, so once again, found vertical asymptote, right? Set the denominator equal to 0. The horizontal asymptote comes when our leading polynomials have the same degree, right? The degree is the power. And then when they have the same power, we compare the leading coefficients, right? In this case, it was 2 over 1. So our horizontal asymptote is y equals to 2. And then we set our x-intercept. We find our x-intercept by setting y to equal 0. We found our y-intercept by setting x to 0, right? From there, we plotted the asymptotes, right? We plot our intercepts, and then we just use the table of values to find out what the actual values are at this point, okay? Now let's move on to the last question. What we're going to do is we're going to find the asymptotes and the intercepts and then graph these functions, okay? So let's get started with the vertical asymptote. Vertical asymptote, we've set the denominator equal to 0, okay? So x minus 6 equals 0. Awesome. VA. So plus 6 to both sides, x equals 6. That's our vertical asymptote, okay? So our horizontal asymptote is, what we're going to do is we're going to compare the degrees of the leading polynomial, and then if they're the same, we're going to look at the leading coefficients, right? So let's look here. This has a degree of to the 1. This also has a degree of 1, so they have the same degree, right? What we can do now is we can say that negative 5 x to the power 1 over 1 x to the 1, right? Because there's always going to be a 1 at the front here. These will cancel, and we're left with negative 5 over 1 equals negative 5, right? So our horizontal asymptote is y equals negative 5. Now let's find our x-intercept, okay? Our x-intercept is when y is equal to 0, okay? So 0 equals negative 5x minus 3 divided by x minus 6. What we're going to do is we're going to multiply x minus 6 to both sides, okay? So that'll become 0, x minus 6 equals negative 5x minus 3 divided by x minus 6. And since we're multiplying both sides, x minus 6. What's going to happen is this side is going to cancel. This will become 0. And then we're left with 0 equals negative 5x minus 3. Okay. So now we're going to isolate for x to find our y value, or to find what the x value is when y is equal to 0. Okay. So I'm going to add 3 to both sides. So 3 equals negative 5x, and divide by negative 5, right? So our final answer is negative 3 divided by 5 equals x. So we have our x-intercept now, right? So we have negative 3 over 5, comma 0. And let's do the same thing for our y-intercepts, okay? So our y-intercept is when our x is equal to 0, okay? So let's just plug in x is equal to 0. So negative 5, 0, minus 3, 0, negative 6. So y equals, this cancels, negative 3. 0 minus 6 is just negative 6, which equals 1/2, right? So when x is equal to 0, y will be 1/2, okay? So last but not least, all we're going to do is use a table of values, okay? And all we're going to do is we're going to start graphing, but we're going to start graphing, but I'm going to set up my asymptotes first and my intercepts, okay? Let's see. Okay, so I have set up my asymptotes and both my asymptotes and both my intercepts, okay? So again, all we're going to do is table of values, right? So let's start off with this left side, right? So that's going to be, we need a 0. Let's do 1, 2, 3, and then let's do -2, okay? That should be fine. Okay, so all I'm going to do is I'm going to plug in these values now, right? When x is 2, y is 3.25. 2, 3, a little bit above that. And then when x is 3, y is 6, okay? So 1, 2, 3, 4, 5, 6. And then we'll do -2 as well. So when x is -2, y is -0.875. So right around here. Right. Cool. Now we can graph this part, right? Right. So it'll look something like this, right? So it'll eventually reach the horizontal asymptotes. This one in particular seems like it'll take a longer time compared to the other functions, right? Compared to the previous ones, which is totally fine. That's allowed to happen. And now let's move on to the right side, right? So numbers that are bigger than x equals 6, okay? Right, we won't need too many points. Generally 3 is fine, but you can always do more. So I'll do 6.5, 7, 8, and 9, okay? Okay, so I finished calculating these points. Unfortunately, they're so huge that they're not going to show up on the graph, but what the graph is going to look like is probably something like this, okay? Realistically, it'll look like something like that, okay? So not perfect. Sometimes you will just get really huge numbers where you can't properly graph them. I do realize that this is kind of tilted and you can't really see the whole thing super well, but this is how you would graph this function, right? So once again, we will find a vertical asymptote that comes from setting the denominator to equal 0. Our horizontal asymptote is we look at the leading polynomials, we look at the highest degree, and if the degrees are the same, then we know that we have to look at the leading coefficients to find what our horizontal value is, right? So -5 over 1, right? Y is equal to -5. That's a horizontal asymptote. We find our x-intercepts by setting y equal to 0. And we find our y-intercepts by setting x equal to 0. I never finished that point. And then what we have to do, if we want to graph it, is we have to just set up a table of values, maybe multiple, depending on how many points you need, and then just calculate and then graph, right? So when x is 1, y is 1.6, right? So we have graphed that, right, over here.